Hi guys, BuildZoid here, and today we're going to try to do some LN2 overclocking on video, which will probably go really badly, but yeah, we'll see. So anyway, I'm using the 12600KF. We're on the Gigabyte Z690 AORS Tachyon. I've got the Corsair engineering sample SK Hynix-based memory sticks installed in the system. And the benchmark we're going to be running today is a little bit of Y-Cruncher, 6-core Y-Cruncher, because for 10-core Y-Cruncher you would actually want an X299 CPU, not a 12600KF, because for 10-core Y-Cruncher you need AVX512, and you also need a ton of memory bandwidth, and quad-channel DDR4 is still just faster than dual-channel DDR5. So, yeah. Anyway, so we've got K-type thermocouples on the memory and the CPU. I'm probably going to be taking the memory cold. Almost definite. Well, like if I don't put any liquid nitrogen on the memory, it'll still cool down. Like I did a session with no intentional cooling of the memory, but because I'm not using a socket heater, the memory still ended up at like minus 30 degrees Celsius. But today I do have the option to take the memory a lot colder, maybe down to minus 120. Yeah, because for Y-Cruncher you need a ton of memory bandwidth. Also, my CPU is heating up. So let's just get into it. Oh, I guess I should mention what equipment I'm using. The thing is, like, I'm using a Kingpin Cooling Venom LN2 pot. It's old. It's not great. It hasn't got a lot of surface area. So like, if you're going to be buying a LN2 pot for for overclocking, I would not recommend this unless you can get it like relatively cheap, which is possible because LN2 pots, you know, like this, you'd have to buy it secondhand anyway. Anyway, let's get into it. So the BIOS I'm using is X3i because for Y-Cruncher we need AVX512 support, and this is one of the BIOSes for the Tachyon where you actually get AVX512 support. And the way you get AVX512 support is you switch over to some old microcode. I'm going to just use revision 09 because that's what I used for the Corsair competition, and it worked just fine. So yeah, we're going to use that. We're also going to disable our E-cores because the E-cores, well, we're running 6-core Y-Cruncher, so we're not going to need the E-cores, and also the E-cores prevent us from enabling AVX512. So enabled, AVX offsets 0. Yeah, that should be good. Now, one thing we need to check with this CPU is if it has that stupid AVX limiter that you get on some of the other Intel. Well, actually, I think it probably has it. Anyway, we're just going to max out all of our power limits. Actually, before we do that, we need to disable all the power management garbage. Like this, and that, and this. Incidentally, disabling turbo boost on anything but a Gigabyte motherboard doesn't work. Like, if you don't have a Gigabyte motherboard, disabling turbo boost is gonna lock your CPU at base clock, so don't copy that. And then disable all that, and nominal for that, or nomial, anyway. I think that's... Oh, right, and then we need to max out all the power limits. Ah, that's fine. And then that's it. Yeah, that's all we really need to change. For ring ratio, we're going to start with 45, and performance ratio, let's start with 40. Let's start with 50. Fixed, 1.45. V-core calibration, we're going to go high. The higher LLCs are, I'd say, overly aggressive. We're going to max out the overcurrent protection, MCPLL. Actually, we're going to bump this ahead of time because that can help with stability, and we're going to max out the CPU PLL. MCPL, well, I'm going to bump this to 150. That can help with memory stability sometimes. Other than that, we're going to max VCC in. We're going to enable XMP. And I think that's it for now, because I do want to first check that Y Cruncher is, like, running properly. Okay, it finally booted. That's normal. The first stop for the system is going to be minus 130-ish, because I need to basically... Well, at minus 130, you can dial in your memory settings. Below that, you can't retrain. And I just realized that my sticker on the thermometer is covering up the negative sign. Zoom out a bit. Man, I'm just not going to get good framing, am I? Well, and this is why I don't do overclocking on camera most of the time. Cameras suck. Okay, let's pull up Y Cruncher. And we're just going to be running 1 billion, and I want to have CPU Z open so that we can monitor the CPU frequency, because I expect it to drop. Because there's this really stupid bug on 12th gen Intel CPUs. You can't actually run heavy AVX workloads with 0 offset, which just, I don't know how Intel managed that, but yeah, so CPU drops to 4.8. Like, I have the offset in the BIOS set to 0, CPU drops to 4.8. Okay, so we're going to need a ton of BCLK. But that's fine, because Z690 doesn't have any BCLK overclocking issues. And I guess I should also figure out, for reference, what kind of score I want. Well, that's 28.714 seconds, and we do have 512 enabled. Good. So for 1 billion with a 6-core, we want... Oh, man. Yeah, so the current record for 6-core CPUs is 20 seconds. So... yeah, we'll see how close I can get to that. I don't have high hopes. The CPU is good, but I'm not, so we'll see. Oh, damn it, I wanted to go to the BIOS. Oh well, no big deal. We're just pulling down, so it's not like I'm losing any kind of progress. Okay, we're down at minus 50. I'm gonna go to 48 and 110, which is gonna give us, man. This is gonna be, yeah, this is gonna be kind of annoying to deal with. Stupid Intel 12th gen. Like, how do they manage that? Just the offset just doesn't work properly. Anyway, man, this BIOS is weird. Like X3i, just in terms of memory training, is wacky. Compared to especially the F BIOSes. Like the F BIOSes, you just keep raising the voltages and things get better, but the X3i BIOS is not like that at all. 0.25. You generally don't need a ton of VCCSA with DDR5. Yeah. We're gonna go 1.5, actually 1.55 and 1.55. Nope, I said 1.55 there. Yeah, that should be good. That should work well. Gonna do 42, 42, 28. We're gonna be using 2T command rate because I want to be able to run high memory speeds. 16 for TFAW, because, you know, go pull everything down. TRFC2, we're gonna go to 333. Actually, maybe 366. Per bank, we're gonna go 266. RTP, we're not gonna touch. Cast latency. Let's start with 32. Max out refresh interval. Minimize TXP. RD pre to 8. WR pre 44. 44. TCKE 4. Then we're just going to set that to 12 and 8. And set this to 12 and 8. Because those otherwise are like horribly loose for no good reason. And then other than that, we want memory timing mode dynamic and real-time memory timing enabled so that we can change memory timings once we're in the OS. Yeah, at this point, I think I'm happy with my settings. We're at, what, minus 60? Oh, boy. So GTL is Gigabyte Tweak Launcher, which is basically like a actually good motherboard utility for overclocking. So right now we're at 5.3 with almost 5 gigahertz ring. I don't think I'm really going to be changing any of that anytime soon. Let's pull up Benchmate and run some more Y-Cruncher. I'm going to max out RTREFI. Apply. Man, mouse feels weird. Okay, there we go. Probably just the lag from the capture card, because I'm controlling the system through the capture card, so... Nope, that's not Y-Cruncher. Just gonna hit run on that. Okay, good improvement. Let's try 112. Now that applies, cool. Just run it again. I think the thermal pad I went with this time for the memory sticks is even worse than what I've been using during the Corsair competition, because that temperature on the memory sticks is... It's not changing very much. Okay, 24 seconds, not too bad. 24.8, that is currently... So that right now puts me in, like, top 25. Yeah, that puts me comfortably in top 25, so we can just keep going higher. So next we're going to try 114 BCLK. 24549, not bad. Okay, let's just keep going higher. 6, apply. Okay. Usually you get like 6 megahertz of extra BCLK on top of whatever you can post, so... I wouldn't, like, I wasn't really expecting that not to work. $24, cool. Let's try 118. Actually, let's try 117 first, and then try 118, and also... I suck. There we go. Okay, 117 applies. Then at this point, I'm already in the top 20. Which, oh, except that wasn't stable. I don't think it's a CPU problem. I think it's a memory problem. Now we're at just 5.6. I think it's a memory problem. Okay, we're gonna try 116. Which makes sense. You normally, like, increasing the memory speed by 7% after you've trained, probably not gonna work, in my experience. So, though I do wonder if we could just run, like, a straight-up higher ratio. Like, if I set it from Tweak Launcher, maybe it won't screw up, so... No, it still drops to 48 on the CPU ratio. Well, that's stupid. Okay, well, we're gonna have to retrain. You know what? Let's try just straight up go all the way to 116. Yeah, the thermal transfer to the memory sticks is miserable. The memory pot is at full pot, and the memory sticks are at -70. Oh, well, that's, you know, like, I kind of expected that to be the case, but... Oh, well. Like, having the memory sticks at -70 is still better than having them at ambient, so... That's the logic behind why I'm willing to use a really crappy thermal pad. Also, the nice thing with the crappy thermal pad is you can't accidentally make the memory too cold. It'll always be just kind of not cold enough. So, you know, it makes life a bit easier in that way. And we're just going to max out TREFI, and then we're going to... Like, the main thing I want to know is if we can run more than 117, so we're just going to go straight to 118 before even running Y-Cruncher, because 1116 already worked, so no point, you know, running 1116 again. $23,695. That gets me the number 18 spot. I think I just heard the thermal pad crack. So, not too surprising. Very much expected, but yeah. Anyway. Yeah, so far very tame on the settings. Like, I think actually, let's just check what the world record is running for memory settings. The world record is running the memory at, and he used a giant screen, so I have no idea. The memory was at 7,400 megabits per second. Yeah, because 3,700 megahertz on the memory. Right now we're at like 3,500-ish on the memory, so yeah, lots of space, like lots of room to improve, basically. So let's try 120. Also, my timings are terrible right now. The world record for Y-Cruncher 6 core is with 30, 40, 40. So, yeah, my current settings are really quite miserable. Yeah, we're at just over 7,000 right now, so... Well, we're at 7,200 right now. Like, to be fair, there's a better way for me to get, like, thermal transfer to the memory sticks. The thing is, so the better way is to literally just put thermal paste on top of the memory sticks. That works really well. I managed to get the memory sticks all the way down to like minus 160 with that method. The only issue is it makes a mess. And so I was like, I don't want a mess. And so I half-assed it with the crappy thermal pad, and yeah, that doesn't really seem to be paying off, because you can see, like, when Y Cruncher is running, the memory temperature starts going up. Or, well, it stops going down as quickly. So... 2307? That's still miserable. Like, it gets me to number 15, and the funny thing is, like, because I don't have a good Y Cruncher 6-core result, literally anything I post that's in the top 20 is actually really good for my overall rankings, which is why I decided to do this session on video, because worst case scenario, I still get way more points than if I didn't do this session on video, so... okay, so it's not happy at this point. Why is it not happy, though? The CPU's at 5.8. Let's try... Well, it could be cache, so let's try that. Also, I'll let the memory heat up. Oh, now it failed even faster. I'm gonna wait for the memory to cool down. Okay, let's try that again. It might actually be the CPU. Yeah, it's the CPU. Yeah, it's definitely the CPU. Also, I just filled it. Well, now that the CPU's cooled all the way down, the memory should get a bit cooler too. Anyway, let's try 1, 2, 3. Oh, I was very upset about that one. Oh boy. Oh, it's very upset. Yeah, okay, so this is the annoying thing with 12th gen. The memory controller craps out as it gets too cold. Because basically a bunch of the voltages controlled by the integrated voltage regulator bug out, so if you pull the CPU very cold, the memory controller actually gets worse, because the voltages freak out, and then If you were on like right on the edge of like optimum voltage settings, it stops working. The thing is, we can't retrain the memory until minus 140. So I need to warm this back up. Yeah, it's still upset. Now I do wonder if we can run TRCD39 at this point. It should be possible with the memory at its current temperature. And this should do 64. This should do 46. Actually, this should do 56. These should do 18. So we're going to try dial in all the like subtimings right now. A bit. TWR 36 and 36. Yeah. We're going to try 120 because the thing is like the memory speed is more sensitive than memory timings to like, well, everything. Almost gave the CPU more LN2, which was a bad idea. I want to get a 20-second score. That's my goal. Get a 20 seconds. Because that is comfortably in the top 10. Actually, it would be top 8 if I get something in the... Well, top 9 if I get a 20-second something. So 22929. I guess I should save something just in case. Also, I accidentally closed Benchmate, so actually, no. What are we at? We're at minus 54. Actually, I think I have Intel memory latency test. Yeah, I do. So just for fun, let's check out the memory latency at minus 150, because this actually pulls a decent amount of power. Let's try the latency test. We're gonna, well, use the quick test because I, like at minus 44, I basically want to restart the system. Hey, we got 45 nanoseconds. Liquid nitrogen is amazing. I don't think I have IDA on this system, so we're unfortunately not going to be able to run that. Anyway, let's restart. Because now I can actually retrain, so we can try boot with an even higher BCLK. Maybe boot with a higher memory ratio. Because we want lots of bandwidth. The funny thing with DDR5, though, is I feel like a lot of the latency actually comes from the really low memory controller clocks, because when you're on liquid nitrogen, your memory latency gets really low as you bring up the memory speeds. So we're going to try boot at 120. And I want to try run it like DDR5 6200. And at this point, we're also going to bump up the vCore, and we're going to bump up the memory voltages. 1.6 and 1.6. Actually, well, yeah. Well, no. So I have an idea. 1.7. We're going to bump this to 1.5. 1.3. And I'm literally like, there's no logic to why I'm changing the voltages. It's just like based on past experience with this board, guess and test for the voltage settings. Unfortunately, with DDR5, you have a bunch of voltage settings that like affect each other in, like they all sort of affect each other, and so it's super difficult to know exactly what's like optimum voltage settings. Yeah, so the nice thing with the crappy thermal pad is I can literally just fill up the memory LN2 pot and it just sits at minus 110. Actually, it's still trying to get to minus 110, so... Okay, that trained. I can't find my phone, so I'm going to have to pull up a calculator on my desktop. So it's 62 times 120. So right now we're booting at 7440, CL30. I might actually have to worry about temperature control today, which is kind of annoying. Yeah. I accidentally clicked on it twice. Tweak it. So right now we're at, 7440 on the memory right now, which is pretty neat. I'm not sure how, like, this might actually just be unstable at this point. That wouldn't really surprise me. So now we're going to drop these to 36 again. Both of them. These to 18. We're actually going to set all of our, sub-timings right now because... And 46. Actually, why do I keep punching in 64? Okay, that worked. And now let's get Y-Cruncher up. Go away, NVIDIA. Go. Get out of the way. And... what temperature are we at? Minus 120. I'm going to try, pull it down to minus 150 and then start the test, because, don't want it to be too cold for the memory controller, but also if it's too hot, then the CPU could crash. Okay, we're approaching minus 150. Hey, it ran. 22.8. Yeah, okay, we'll actually save this. It's not, as far from perfect, but it's something, and so we'll save that. Because, yeah, that's just faster with, less CPU speed, less cache. And just because better memory, we're getting a better... this is the best score so far, and it's literally just memory settings right now. I'll put this here. And one more CPU Z window, because we want memory, mainboard, and SPD. And actually, what I also like to do is include my settings over here. Just so because I also use the screenshots for my own reference. Okay, we're actually going to just cover up part of memtweak over here with this. Because the motherboard tab is, optional. But, yeah, anyway. And then SPD for the memory sticks. And now we just hit save. Oops. Save. There. And now we need to close all the CPU-Z windows because the monitoring that CPU-Z does lowers benchmark scores. Literally any monitoring software lowers your benchmark scores. It's really quite frustrating. Even the built-in monitoring functionality of something like 3D Mark with system info, that's actually bad for 3D Mark scores, system info is. Now, you can't run 3D Mark without system info. That's not allowed for the 3D Mark rankings, but if you could, it would be better, you would get better scores. We're going to try TRCD40 this time as well. Okay, might be too warm. Maybe not enough voltage. I'm just gonna hit it with 1.6. Okay, no. It is very upset about memory. Actually, maybe... Please don't crash. Hey, it finished! That was quick. 22665. Now we get to go through the exercise of opening a bunch of CPU-Z windows again. I really wish memtweakit was a, like, accepted alternative to the memory tab of CPU-Z, because, like, it just has more information in it. There we go, and saved. Also, I need to get more LN2. Oh, okay, well, that doesn't run. So now we're just going to restart. And I'm going to try that, but without adjusting any of the sub-timings. Or really any of the timings. Because I wonder, like, are we reaching the limits of the memory controller or just, like, memory sticks? Because if it's the memory sticks, then me pushing the timings around is probably not helping. If it's the memory controller, then it shouldn't really matter. But, okay, that's not stable. So it might be the memory sticks. Yeah. So what we're going to do now is we're going to drop the memory ratio, and what's really cool about Z690, you can actually... Well, actually, I'm not sure if it's universal to all Z690 boards, but on the Tachyon, if you drop the memory ratio, it'll actually drop the memory ratio without retraining. Which means, like, if you're at full pot or at, like, temperatures where you can't retrain, you can still change the memory ratio. You just can't change any of the memory timings because memory timing adjustments require a retrain. Now, admittedly, if you make a too big of a ratio adjustment, you'll actually just have massive instability. So, you know, like, there are limits to how much you can change the ratio. But for the most part, yeah, you can just kind of change the ratio on the fly. And we're actually going to go up to... sure, why not? Like, it won't retrain for that. It shouldn't retrain. So the memory sticks are at -1. Yeah, this thermal pad is worse. There's other thermal pads that I've used that would sit at like -120. This one's terrible. This one's stuck at -113. Um, we're at 5.58. Memory is at 7,300. Yeah, so it looks like we're reaching the limits of the memory. Because now 122 runs. The thing is, well, we don't have the timings tweaked, so too early to say anything. So again, we're going to keep raising the BCLK, then once the BCLK is maxed out, like back it off a bit, fix the timings, hopefully not cause it to get less stable by doing that. Let's try 124. Go away, NVIDIA. Oh, so it's upset about that. Really? Already? I wonder if it's just vCore. The thing about a benchmark like Y-Cruncher is, like, if you try to max out the memory separate from the CPU or the CPU separate from the memory, you're like, how much work the CPU is doing is directly tied to your memory speed. So if you only max out the CPU, your CPU is going to do higher frequencies than if you actually had good memory settings. Or, you know, if you have bad memory settings, you're going to get high CPU clocks. If you have good memory settings, you're going to get worse CPU clocks. But the best score is going to be like finding the balancing act between those two. And the best score in Y-Cruncher is also going to be the hottest running, because that, like, if you get the best score, that means the CPU is doing the most work. So yeah, kind of a fiddly benchmark. And we are going to save this. I covered up my CPU Z icon. I'm not going to do the full fancy validation for this one just because the timings are still garbage. Like, I just want this saved in case this ends up being my best score, so we're just going to save it like this, because this is the requirement for hardware bot, is just CPU Z CPU tab and CPU Z memory tab. We're just going to save that. Actually, I think this window might be... There. Save. Obviously, this would be easier if I had a bigger monitor, but all of my monitors are 1080p, so it's not really an option. Which is also probably a big part of why a lot of people use like 4K, like just big monitors on hardware bot, is because it makes validations a bit simpler to do. Anyway, let's try 126 with 1.65. I let the memory get way too warm. Okay, yeah, that just insta-crashed. Man, this is a really difficult benchmark. Like, the balancing act of keeping everything cold enough, but not too cold. I'm kind of tempted to try lower the ring ratio just because I have a sneaking suspicion that that might be, like, crashing it. Because the ring requires a disproportionately high amount of V-core compared to the cores. It might also be more important for overall performance, but we'll find out, I guess. Yeah, so the ring is evidently holding me back a bit. I'm pushing it too high. Man, this benchmark is so hard. Like, Cinebench, you can run like 6 gigahertz plus ring clock, and here it's like, oh, 5.5 gigahertz, and it's just like, nope. Okay, let's max out this. 36, 36, 56, 46. The 220s over here are less important. Let's drop these to... Actually, might be able to do 39. TRCD is a pretty big deal for performance in literally anything, because TRCD is just good. Also, I forgot to save this, but that's just fine. I have complete confidence that this will run. And it didn't. Good job, me. Oh, it's very upset now. I've run out of LN2 in the thermos. It's not ideal. Yeah, it's empty. Damn. Well, it finished before I right? It'll finish. Yes. Oh, shit, that's terrible. Why is it so slow? Well, that's not great. Damn it. Okay, maybe it... Well, we'll try it really cold and see what happens. It doesn't run. The timings are fine. Those really shouldn't be causing any issues right now. Okay, nope, it's very upset about just about everything, apparently. So I think I'm going to drop the memory ratio again. Because, yeah, we're memory limited. I think 5866 is a real memory ratio. The one downside to gigabyte boards is a lot of these memory ratios don't actually work. I think 5866 is real. I guess we'll find out. Actually, we can just check in the BIOS. Because if it's not real, it'll actually boot us at one step down. Oh, I decided to retrain. And the retrain failed. So I guess that ratio isn't real. Well, good to know. So we're gonna have to limp mode. Oh, and it's too cold and it doesn't want to reboot. Yeah, it's too cold right now. The CPU cold. This 12600 KF needs to be at like minus 135 to boot. Now it should boot. And boot it does. Actually, I just had a... Well, actually, we need to... Because I just limp moded, so... Can't check that right now, but... 5800 is real, right? Okay, it's really not... It really doesn't want to retrain right now. I guess I could go all the way down to 50... Well... I mean, the other option is we could just loosen out the primaries. 44, 44, 32, 30. Actually, I'm going to go for 32 on that. Yeah. We're actually going to lower that. Like, DDR5 on LN2 is weird with the voltage behavior. I'm going to try it this way. Oh, so that trained. Okay. Now, I want to check one other thing, because it kind of looks like I might be the only person who decided to deal with the whole Y Cruncher gets downclocked by Intel's crappy AVX offset management. So I want to see if maybe with like a really high ratio it's not an issue. We're going to have to drop the BCLK a bit for that. Because I don't know if it's like a fixed 200 megahertz drop or if it's if it goes to the 48 ratio. Because I think it just goes to the 48 ratio, so... X5... Let's find out. Yeah, I just dropped straight to 48. So this is literally pointless. Oh, that insta-crashed, apparently. Oh, it is very upset at 126. Apparently lowering the memory voltage was not the right choice. Oh yeah, it is very, very upset. I hate DDR5. Like, look at this behavior. It's like, it was running fine just, like, minutes ago, and now it's not running fine. And why isn't... Admittedly, I do have the cache pretty high right now, so let's try 42. No, it's still upset. Stupid DDR5. We're going to be dropping all the way down to 56. .56 is definitely real. That is a very real memory ratio. So that, like, has to work. Also, I did drop the memory voltage, so actually, we're going to go back in and fiddle with that again. I really wish there was a way to see what happens to, like, memory signals as you fiddle with the voltages, but, I mean, the equipment to do that kind of thing is way too expensive. Gonna try 1.7, maybe. Let's try that. That might help. It might not. It's DDR5. You never know. I don't really want to mess with VCCSA. I do want to lower the timings because, like, this is a memory benchmark, so... Don't want to limit myself for no good reason. Because I can't change the cast latency once it's booted. I can change everything else, just not cast latency. Oh, and cast write latency, which is just like the other... That's like the flip side of the cast latency timing, so... Same thing. So technically the motherboard does have a setting in the memory settings that should boost memory performance at the cost of, like, stability. So, yeah, I'm not sure I'm gonna turn that on. Because my past experience with that setting was like, yes, I do love seeing blue screens all the time. So, yeah. Then again, that was with the 12900K, and the 12900K's memory controller is a pile of trash. So maybe with this CPU, that setting actually is okay, but yeah, I don't know. Anyway, we need to cool down, and I'm running out of nitrogen again, so gotta refill. Okay, let's run. And that was, of course, miserable because our memory speed is now way lower than it used to be, but let's see if we can run 126. And the answer is apparently yes. Hey, we're getting somewhere. Let's try 129. I kind of feel like maybe trying 1T command rate would be worth it. The thing is, 1T command rate, like, the behavior is so different. I mean, and this is still slow, but all the timings are terrible, so that's not too surprising. Let's try 130. Actually, so we're at like 6.25 now. I'm kind of tempted to see if I can just full pot it, because that would make my life a lot easier. I wouldn't have to worry about pouring so much. Speaking of pouring, I should probably raise the voltage a bit, considering the frequencies we're at. Oh man, now it's really upset again. I wonder if that's because of the temperature or because of the BCLK. Let's try 129. Okay, it might actually be because of the BCLK being too high. Hey, best score so far, but we're still in the 22 seconds range. Is this so bad? I mean, we do have the TRCD set to literally 44. Should be able to do 39, no problem. Yeah, with the memory at a minus 109. Also, TREFI is trash. TWR is trash. Tertiaries in general are trash right now, right? Like, we've got this one, and this one should be that. This should be 18. This could be 7. This can probably be 10. Why aren't you 18? And this one can be 7, and if we hit apply on that, it doesn't even crash, and now Y-Cruncher won't run. Hey, that is quite the improvement. Hey, first score under 22 seconds. So now I'm what? In like... Yeah, I'm at the very bottom of everybody, like all of the LN2 results. Actually, no, that's not true. There's one LN2 result that's like 23 seconds, so... But I am at the bottom of most of the LN2 results anyway, so not really doing that great. Oh man, this benchmark's so difficult. I guess like the next step is to try like 133 BCLK, so I can really get the with a full retrain and maybe CL32. Come down. So I actually want to let this warm up a bit right now. There we go. You know, just for fun, let's hit the Intel memory latency test. Because I do need to wait for the system to warm up a bit so that we can do the memory retrain. Also, having CPU-Z open in the background is probably not ideal for memory latency. Yeah. Let's just close everything. Because I can't retrain until we're below above minus 140. This is taking forever. Did it crash? No. Okay, well, screw this. Like, I do actually, like... Liquid nitrogen costs money. I don't have all day. Okay, let's try 130. And we're also going to try that one setting that, like, if it works, it'll massively improve performance. If it doesn't, then stability goes straight to hell. So, yeah, we're going to do 42, 42. I'm actually going to drop this at this point because we are very cold. It trains. Now does it run Y-Cruncher? Or more like, does it get into Windows because I turned on RTL training, so... I think it crashed. Yeah, it looks like RTL training did exactly what I thought it would do, which is make the system completely unusable. Like, I'll try it one more time, but if it doesn't start working, I'm giving up on it again. And actually, I might try 1T command... Well... I think I might try 1T command rate instead. I have a lot more experience with 1T than I do have with RTL training. Because every time I've tried to use RTL training, it just turns into, oh, I can't get into Windows anymore. Like... Oh, wait. Blue screen in 3, 2... What? We're on the desktop? Oh, the mouse is freaking out. Its timing is 4, right? 60. 50. Yeah, oh boy. Oh boy. This will be interesting to see if this works. We do need the extra voltage for sure, I think. Because right now we're literally running the highest CPU clocks for the entire session. Yeah, 6.24. And not an instant crash. Amazing. Like, it's actually running. Man, my 12900K is so bad. Like, every time I tried to use the RTL training option, it just immediately blue screened. Everything. You couldn't sit on the desktop without the system dying. And it's just like, look at this 12600KF. Just absolutely demolishing that pile of trash that is my 12900K. I hate that CPU so much. Like, I spent so much time trying to get RTL training to work. The answer is, no, you don't get RTL training to work because the memory controller doesn't know how to train the round trip latencies. And so you can't. There's nothing you can do about it. Well, that's nice. At least now I don't have to feel like I was doing something wrong, because, yeah, you just get a better CPU and then the setting works. Like, what else did you expect? Truly, the 12th gen memory controller experience. It's not great. They're bad. There we go. Because, like, I literally tried to use the RTL training option at XMP, and it didn't work on the 12900K. Like, I was that desperate to get the setting to work, and it's just like, nah. It just doesn't work. Oh, well, that's a good discovery to make. Let's try 131. I already applied all of this, right? Okay. Yeah, we're going to keep the round TRCD loose for now, because that timing tends to cause the most issues. Now, I'm not sure if I can commit to going full pot or not. I guess we'll see. Nope. That's new, though. Like, that whole hard shutdown thing, I've not seen that before. So now I need to wait for the system to warm back up to -135 before it'll boot. There we go, it's up and running again. Only unfortunate thing is we need to retrain. And it doesn't want to. Oh wait, looks like it worked. Yeah, it worked. Okay, cool. So I'm getting sick and tired of actually changing the vCore once we get into the OS, so we're going to go up to 1.65. The main risk with setting your core voltage in the BIOS is that if you like forget what voltage you left in the BIOS at the end of the session and you don't clear CMOS, you can potentially kill your CPU. Y-Cruncher 126KF. Kind of... no, everything is working. I should not mess with stuff. Kind of tempted to just try that. Oh, wait, what? The BIOS died. Okay, maybe I don't get to change anything. I think the settings are locked in at this point. I feel like that happened because the CPU got too warm. Or maybe the memory. Two, 3, 6, 3, 6. Well, let's try TRCD first this time and leave the tertiaries alone. P-core, ring. We're going to try less ring clock just because it does kind of require a ton of V-core otherwise. 131. Move that out of the way. Also, I need to get more LN2. Okay. Where's bench Y cruncher? There we go. What temp we at? Too warm. Oh, and it died. Man. Oh, and it crashed so hard it wouldn't reset properly. So, to be completely honest, at this point, I kind of feel like not continuing with the video. Not because I want to stop the session here. I want to keep working on this. I just don't feel like commentating it any longer. So, yeah. That's it for this video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. And then I also have a Bandcamp where I upload music. You might want to check that out. So, yeah, there's links to all of that down in the description below. If you want to support me through any of those means, it would be much appreciated. And that's it for the video, so thank you for watching, and goodbye.